All right, guys, welcome back to the shack. Today we're going to be taking a look at a CNC that is relatively small. It's kind of what I would throw in the category of a beginner CNC, compact, hideaway CNC, whatever you want to call it. It's a really small machine, unlike this one, that you can learn the fundamentals, the basic principles are all the same as it is on the bigger machines, but it's a lot cheaper to get started with, and you can create some pretty cool little projects with it as well. And as you can see here, this is a little 3D or 2.5D, however you want to call it, engraved that I did with the machine using the bits that it came with. And you can see it's just good results for small things. Now, you know, it's not the fastest machine in the world, but as long as you're doing small items like this, it'll get the job done and on a pretty small budget. So if that's something you're interested in, stick around and we're gonna go over the machine and point out some of the things that I like and some of the things that I don't. So we'll be right back, guys. All right, guys, so there it is. This is the Lunyee, and I hope I'm saying that right, 4040 machine. As with a lot of the beginner machines, it's going to be like a 400 by 400 millimeter work area. This machine is a lot lighter and a lot different than some of the ones that I've tested before. And the big thing that leads to that and kind of helps with the weight of the machine is this one is belt driven, like a lot of the lasers and stuff that we use, whereas the ones I've tried out in the past were ball screw driven. Another thing is this machine out of the box, this is the spindle that it came with. It's substantially smaller than the one that's on there now, but they sent me the upgrade kit for it to upgrade it to this bigger spindle. Now, I would like to point out, adding this spindle, the bigger spindle to it, is going to give you a little more stuff to keep up with. As you can see, my little DIY box right here that I made. This has the controller, both the power supply for the spindle as well as the power supply for the CNC. I put them on, mounted them on this little board here, just to kind of keep things from being cluttered. Guys, if you know me and familiar with the channel, cable management is something that is just really a must in my opinion. Out of the box, the way it came originally, even without the upgraded spindle, I was making projects. I had the bits, I had the collets. It even come with a little pack of the smaller 1/8 inch bits. I haven't used those. I'm just I'm just a little particular to 1/4 inch bits these days. But all in all, the assembly wasn't difficult. Like I said, it's a little different than what I'm used to with some of the ball screw machines. This was more like assembling a laser than it was a CNC. All right, guys, so fast forwarding through the assembly here a little bit. This is the base of the machine. This is like the very first step, and I am literally following the book just to try to make sure of how easy it would be to follow along with it. And I had success. I didn't have to take it apart, put it back together or anything. I will say that this subframe that they've kind of built right here tends to space the entire machine up off the table a little better, adding a little bit of support in the middle of the machine. That's something that you don't always see with some of these smaller CNCs like this. So I think that was a pretty good deal on their part. I would still recommend setting the machine on a good flat surface just to ensure rigidity. But as far as the spoil board pressing in or whatever, those two pieces in the middle are going to kind of help with that and ensure that it doesn't, you know, as the bit's pushing into the material, it's not bending the spoil board down. So basically, once you get that base right there constructed, the rest of the pieces kind of go on fairly simple. I did have right here in just a second, you're going to see I kind of get hung up a little bit. And the reason for that is that this piece is actually supposed to have been together like the one on the other side is, but my shipper apparently dropped the machine and, I don't know, played football with it, who knows. But they had ripped a couple little screws in there that were really shallow threaded screws. They ripped them out, and so I had to find some longer screws to go back in the holes and put them in there because there was plenty of threads left It was just the ones got damaged where they had dropped it or whatever they did. So a few minutes later and some longer screws, and I get this thing put back together. Brandy is actually sitting there like questioning what I'm doing, and I didn't pay any attention. Do not put the stepper on the inside like I just did right there. Make sure you put the stepper toward the outside. And Brandy, this is where I get the I told you so, and she does offer to help hold it still while I'm putting it together, but she did give me a couple of I told you so's, because she's watched enough of these things go together that she realized that I was messing up, even when I didn't realize that I was messing up. So once I got that little episode behind us, it goes a lot quicker and a lot smoother. Altogether, the instructions were fairly easy to follow. I will tell you, on putting these things in there, they were a little snug. Like they were cut exactly the right size to fit in there. I was fixing to call for a rubber hammer, but I managed to get them lined up where they sit down properly. And there's plenty of screws holding this thing together. So as you can see, luckily I got my little power DeWalt screwdriver there, which is pretty handy. You just gotta be careful not to cross thread anything, because it's actually a lot more powerful than you'd think it would be. So I got the bed on there, and now for the gantry. The gantry really wasn't as difficult as I was suspecting that it was going to be. Like I said, for the most part, other than me having to put that piece back on the side rail, had that not gotten broken by the delivery guy, we could have had a lot better go at it, and it would have been a lot quicker. But still, even with that, this build's not terribly time consuming. But you can see I'm taking my turns, going around, getting everything lined up, and then going back and tightening them down. Got that on there. These little dust shields right here are pretty handy. I didn't think I'd like those in the beginning. They serve two purposes. One, it allows you to keep the dust and stuff inside the work area if you're not using dust collection or just don't want to listen to it. And secondly, you can take those little pieces of acrylic off, hinge the controller around to the side, and it's like a big pass-through. So with this machine, even though you're limited to 400 by 400 for your usable work area, you could do tiling, or you could, just use a larger piece of material in kind of a pass-through type situation, because there is nothing in that work area once you take those little magnetic pieces of acrylic out of there. So now I'm just down to the wiring, getting everything situated, cable management, and I spend way more time on cable management than I probably should. So we're going to fast forward through that and show you guys what it looks like the further we get in. All right, cable management is complete. Now we've just got to attach the spindle. Like I said, this is when I first got it. I did not have the additional spindle, the upgraded spindle, and I wanted to test it with this one just to see how well it worked. That little dust shoe you see right there, guys, that's actually made for Genmitsu machines, but it did fit this one. But I decided that since it didn't come with it, and it had this little dust shields around the machine, that I would just not run it even after I put it on there. So, all right, so here we go, guys. Doing a little testing. This is a little 3D file. You look at right there in the top left corner. This is basically just a file that I've got in Vectric. It's a 2.5D file that I showed you early on in the video. This is running the original stock spindle. I'm doing the rough and pass for this file in Vectric. And I'll kind of load this video back up here in a minute and show you guys how to go about exporting this thing as far as the G-code and how simple it is. It's really not hard. If you use Vectric or some of the other software, you just simply need to use the .tap post-processor and export the file, and when you do, the machine will recognize it and cut it. As you can see, this 1/4" bit, I don't know if it's the frame rate of the camera or what, it did a really good job, but looking at this 1/4" bit on this frame rate on the video, it looks like it's slowing down a bit, but it did a really good job with this bit that they provided. Looking at the video, like I said, you can almost, it looks like it's slowing down, but I did not notice that watching it, with my eyes as it was running. I am standing by, just keeping an eye on the machine, because this is, I've ran a few other tests with it, mostly with, just little small carving bits and stuff, just checking the functionality of the machine. This is actually the first, real deep, I say real deep, the first deeper cuts that I'm doing. You can look at that pass depth right there. That's pretty, impressive for that little tiny spindle, in my opinion. So it's doing a pretty good job at working this material off of here, getting it roughed in for the 3D pass. And yeah, my little camera was getting a few chips thrown at it. But if you notice, the little boards and the boundaries around there, it's catching a lot of those big chips. Now, you're still going to have dust. So dust extraction is a good thing. But for the most part, it's containing a lot of the chips. So we're going to go ahead and skip over to the 3D pass just for length of video sake. All right, so here we go. We got through with the roughing pass. You can kind of see how it did. It basically just removes those big blocks of material, and that's just to take the workload off of the smaller bit and increase the job efficiency as far as time, because that bit removes the material a lot faster than what we got coming up here. What I'm going to be using for this 3D pass is going to be a tapered ball nose bit. It is a 1/4 inch bit, and I am still running that 1/4 inch collet with that smaller spindle. So if you were wondering what the possibilities were with the smaller spindle, that's what I'm running on this engrave. It was after this video when I received the other one and had to, attach it to the machine. So this is going to be that little bit right there, and we're going to go ahead and I'm going to let that. And all of this video right here, guys, of the machine working is in real time. This is the one thing that I will kind of warn you of. With this machine being belt driven, it's a lot easier to move it by hand. So you're going to need to make really sure to check when you change the bit and make sure that you put the bit back on the corner and that you set the X, Y, and Z. Now, part of the problem I had with this is my roughing pass had removed the material from that corner. So I'm having to basically set the Z based on what was the surface of the material, which is right there. And you can move the X and Y relatively easy by hand. And then there's that knob up on top of the stepper for the Z. Then once you put all those in where you need them, say I set the X and Y earlier, and then I just set the Z now, once I got it to the Z height. And I'm just going to send the file. So that's one thing that you'll have to remember is moving when you're changing the bits with the belt system. It's a lot easier to move the gantry than it is with, say, lead screws or ball screws. So just remember that when you're doing bit changes. So now I've got the machine sent to do the finishing pass. I'm gonna let it run for a few seconds here, and you'll see. I think it's the frame rate. I think when that thing gets up to a certain speed, it makes it look like it's slowing down, but I think it's actually going faster. I don't know. Maybe it's the camera. Who knows? But it did a good job. So I'm gonna let this run for a second, and then we'll skip towards the end so you can actually see what it looks like. All right, guys, so about 20 or 30 minutes or so have passed. This whole thing, I think, the 3D, as well as a roughing, looking at the video, it looks like it took around 30 minutes, 45 minutes to do it. So this is the final 3D pass. And I know what you're saying. It just looks like a piece of wood with a bunch of sawdust on it. And that is true. Like I said, I decided not to run a dust shoe on it because I wanted to see how effective the little side covers and everything are. If you'll notice, this one does have the little metal gates or the little metal side bodies. That is intended to keep material from getting on the rollers that it's sliding back and forth on. And that's a big deal with some of the machines because, as you can see with the rollers up top, it has those on the sides as well. And those little chips and debris getting over there, getting shoved down into the rail and just attaching itself, sticking to those wheels, can cause some consistency issues with roller-powered CNCs like this one. But they did take and make those little pieces of metal on the side to where they deflect and cover up those parts and kind of discourage that from happening. So here shortly, you will be seeing the final results of this this little engrave. Now, my file was a little bigger than the material, or smaller than the material, but this was just a test piece. So y'all bear with me. I did go clean it up with the sander and the table saw and everything to make it look a little better for presentation. All right, so there you go. You can see the machine moving up to its safe Z height and moving over. Once it gets back to the X0, Y0, it's going to turn the spindle off. All that works automatically. And now all that's left is to just get this sawdust off of this engraved so we can see what it looks like. But that is, like I said, y'all saw it in the beginning of the video, so it's no big surprise. But that's the machine actually making it. And doing this, what I did is I took a piece of old MDF and put on the work bed with some clamps. And then I used tape to adhere my little piece of material to the work bed. And the reason I did that is mostly because I didn't want those clamps around the material in the way, and by doing it this way there was no risk of me, you know, if I'm doing it, because I did a lot of different testing, I didn't have to worry about getting into the bed on it also. So there we go. All right. The one gripe that I had with the machine, guys, is when they sent me this spindle, I got the little silver box, which is the power supply for the spindle, and the spindle itself. No instructions, no nothing, no wire, no anything. So I had to take an extra 120 power cable that I had, and I'm fashioning myself a power cable to connect to this thing here. And I also had to go over to my automotive box and grab myself some wire and make myself a little wiring harness to go to the spindle. And once I did that, of course, I went ahead and made sure that the output of the power supply was the 48 watts as was indicated on there. And then got the machine out and put everything together. But that was a little that was a little buggy there. So if you're wanting to get the spindle upgrade from them, unless they improve it, just know that it's going to require you to have a little bit of electrical knowledge. It wasn't complicated, but I did have to fashion, like I said, my own cabling because it did not, the box didn't have it in there. Once I did that, it's as simple as taking the other spindle loose and then swapping the spindles out. I did put quick connects on the new one, so that I could be able to just plug it in, and we're good. All right, guys, so there it is. Okay, it is a belt-driven CNC. Comes with a decent spindle for doing smaller things, woods like poplar, pine, some of the softer woods especially. You're going to be able to do some really good speeds with those. Really fine detail. So far, it does a really good job with the 3D. I was a little worried about the belts. I'd never had a CNC that was belt-driven before. I talked to my buddy James Dean, and he said that he runs a lot of belt machines and that they do a good job. And obviously, he was right. So all in all, guys, if you're just wanting to get your toes in the water of CNCing, this machine is almost as inexpensive as the software that it takes to run it. Your options, of course, for the software are going to be Vectric, which is what I use. You've got Carveco. There's a bunch of other softwares. If you're really into machining, you can use Fusion 360. There's tons of softwares out there that you can use to come up with files for the machine. But all in all, right now on Amazon at this moment, this machine sells for $548 on the Prime deal, and it is the machine with the standard spindle. Like I said, I'm sure there's an upcharge for the bigger spindle, but just for the machine, $548 to get your feet wet, it's not a bad price. The other machines that I've tested out for the most part have all been higher. This is probably the cheapest CNC that I've ever had in the shop. So, but it does a really good job considering you're just going to have to be patient and be smart with your feeds and speeds. Start out conservative and work your way up from there. But there's a lot of machines out there that are comparable to this one. So if you see speeds and feeds for a machine that is similar, then you can a lot of times go with those and maybe knock a little speed off of it to be conservative and have good luck. I don't have a whole lot of speeds and feeds with it because I've done a handful of tests. Most of them were on plywood, plastic, and this poplar that I had left over from a build. So, but all in all, guys, like I said, it's not terrible. One of the things that they did do that I kind of like is that the front and back have this acrylic with the magnets on it. And that does a really good job if you don't have dust collection, because I think these machines, a lot of times people, it's a budget machine and you don't want to spend more money on dust collection than what the machine costs. So by it having that keeps the majority of the chips and stuff contained so you can get them with a shop vac. I do know, however, that there are some dust shoes out there that are made for these spindles, these Chinese spindles, that do work with this machine. I actually put one on there and ran it, and it worked. But a shop vac is way too noisy for me to be running with the CNC. I've gotten spoiled. So I took it right back off just because it was more noise than it was worth. I just waited till the engrave finished, used a shop vac, cleaned up the mess. It was much, much more pleasant in the shop. But anyway, guys, there you go. That's it in a nutshell. Don't know what else exactly to tell you about the machine other than it actually looks pretty cool. And it runs well. The lights, it's a cool addition. I like the lights on my big machine, and this little guy matches. All right, guys, so that's going to wrap it up for now. Like I said, not a bad little machine. If you want to look at it, be sure to click the links out down below. We'll be dropping some Amazon links to the machine and the upgrade and all that. As long as I can find it on Amazon, it'll be down there for you to look at if you need any more information. So until next time, be safe and have a good day.